So let's start off with the intercepts. So if we're looking for the x-intercepts, that means y equals 0. So then I have 0 equals 3x over x squared plus 9. Now, one thing to take note of here is notice the bottom is prime. What that tells me, it tells me that I'll never get a 0 on the bottom, no matter what real number I plug in. So that's kind of a nice thing there. Actually, I think 3i would make it 0, but that's imaginary. And we're dealing with real numbers here because we have to graph them. So anyways, so that tells me that the bottom will never be 0. So I'm actually looking at where 3x equals 0 because it wouldn't make a difference for the bottom. Okay, so anyways, where 3x equals 0, I divide by 3, both sides, and I would get x equals 0. So if I'm looking for a x-intercept, the x-intercept is going to be 0, 0. That's it. So now let's try the y-intercept. That means my x is 0. So I'm just going to plug in 0 for x. So I'm going to get y equals, and I'm going to plug this in because I know you guys are probably uncomfortable anyways because we're dealing with a rational function. And this is going to equal 0 on top and 9 on the bottom, which equals 0. So this intercept is going to be 0, 0. Okay, so now let's take advantage of our space here, and let's find we'll see if these are symmetric with respect to the x, the y-axis, or the origin. So the x-axis then. Now remember, we're crossing over the x, so our y is going to get negated. So 4x squared. Oops, what am I doing? I'm doing the last problem here. Whoa, okay. So my y is going to be negated. So negative y equals 3x over x squared plus 9. And clearly we can see that, yeah, that's not the same equation. There's no simplifying it so that it is. So no. So the y-axis, let's try that one now. And that means my x is going to be negative. Okay, so that's going to be y equals 3 negative x over negative x squared plus 9. And what's going to happen here, this isn't going to work either. When I write this out again, this is going to be negative 3x on top and x squared plus 9, which is different from the original because this one here has a negative on it. So this would also be a no. So now for the third one is the origin. Okay, that means I negate the x and the y. And this is what I write. So then my negative y is going to equal negative 3x over x squared plus 9. And I can divide both sides by a negative 1 or times it by negative 1. And I get y equals 3x over x squared plus 9. And what I see here, that is the original equation. So I write yes. So the last one is just the origin. It's symmetric with respect to the origin.